Good afternoon, everybody, and welcome to our last session in this October 2022 series, Worker Focused Science and Prevention. Please, if you weren't able to join us for all 5 weeks, go back and take a look at our amazing content. We had some really good information on the healthy workers, healthy workplaces initiatives, as well as Occupational Illness Prevention Steering Committee updates. And some neat announcements about Silica tool coming to Ontario from BC that we had worked on a couple of years prior. And today we're going to see the user experience of that. So today is kind of tying it all together with the best part, trying to make it easier for everyone, trying to mobilize this knowledge that we've been sharing and share some tools to help everybody in their efforts to help us prevent occupational illness. And Dr. Joel Moody, our CPO, our Chief Prevention Officer, will be back to close us out today. So yeah, thank you for coming. We're putting together the session. There are quite a few of us control bandits, we like to call them out there. Dave's all coined that phrase with us another session of October in other years. And I'll remind us of a Workplace Health Without Borders session coming up next week with a similar content, and throw that in the window. Kevin, if you're around, feel free to throw that in the chat window for folks, but I'll remind us again later. So without further ado, let's share some of our best practices around knowledge mobilization. Oh, sorry, did someone have something in there that I missed? Oh, my bad. Okay. Our first speaker, sorry. No, nothing wants to work today, is Thomas Tenkate. So welcome, Thomas. Thomas is an associate professor, and Jen, you can let Thomas share his screen, and was director from 2011 to 2020 at the School of Occupational and Public Health at Toronto Metropolitan University, formerly Ryerson University. He's worked in Australia, the USA, and in Canada in the fields of environmental health and occupational health and safety. He's been an academic for 20 years, and prior to this, worked in a variety of government roles for 10 years. He has qualifications in environmental health, industrial hygiene, management, education, and risk management, including a Doctor of Public Health from the University of Alabama at Birmingham, USA. His research interests involve risk assessment and risk management in occupational settings. So welcome, Thomas. And I meant to say happy Thanksgiving to our neighbors south of the border, reminding me, Thomas, from your studies. We have Todd here introducing a speaker, and Angela giving up part of her Thanksgiving Day next. So thanks and welcome, everybody.
Great. Thanks very much, Kimberly. And hopefully you can see my screen. It's hopefully it's sharing okay.
Looks great.
So, great. Thank you very much. So yeah, thank you for the opportunity to present today. The title is called Reducing Risk Chemical Management for Small Business and Changing the Workplace. And so I'd like to first start just acknowledging the research team, and that these series of projects have been funded by Ontario Ministry of Labour and WorkSafe BC and my own university. And we've had a range of partners to support this through, including OHCOW and a range of unions and other safety associations and the like. So we're really privileged to have support throughout the series of projects that we've done that are all been under this what we call our CHAP Tools banner. And so just to sort of start off talking about chemical safety and chemical safety assessment. So basically there's a large number of chemicals that are commercially available, but only a small number have authoritative exposure limits. And so then you say, well, how do you make an informed judgment of the hazard and the risk for the bulk of the chemicals out there? And so that was really what started us in the process, and also in terms of chemical safety management. There's of businesses out there, the large majority of businesses are small and medium sized, and we know that this sector has a lot of difficulties and issues in really assessing risk effectively because of resource limitations. Whereas if having a look at the violations from OSHA in the US. They base the inadequate management of chemical hazards is the second most cited regulatory violation, and across all workplaces, no matter size. So I think that not just for small and medium-sized businesses, but for all businesses, appropriate chemical safety management is a ongoing issue, and something that is important to do effectively. And so our projects that we've termed CHAP tools, or so CHAP stands for Chemical Hazard Assessment and Prioritization. These came out of a meeting we had a few years ago with a union representative who was really identifying that that assessing the hazards and risks of chemicals in small businesses was an issue, and they asked, is there a way that we can look at doing something and developing some resources to assist with this? And so that led us on the journey to try and develop resources, particularly for small business, that would better help them understand the hazards associated with the chemicals that are in use, and to then also do simple hazard or risk assessments of the chemicals, with the idea that they're able to then prioritize the most hazardous or risky chemicals to then focus their control measures on those the highest risk ones or highest hazard ones. To be able to do this, we said, well, what is a key source of information for small business for chemical safety? And it's really coming through safety data sheets. And I'll at the later part of the presentation, I'll swing back to talk about safety data sheets. And we also wanted to say, well, how can we sort of do something or provide resources that can integrate and link to what's being done from a perspective of WMIS training, and can that help WMIS be more contextualized? And I'll talk about that later. And so overall, our goal is to really try and engage workers more in chemical assessment. So the CHAP tools that we've developed over a series of years now, we've developed 4 tools. The first 3 tools are hazard assessment tools. We started off by developing a paper version of a hazard assessment, and this was really using hazard banding as the basis for the hazard assessment, but doing it within what I call a pen and paper version. For all of these tools, we worked with industry. We had a range of workplaces trialing the tools, as well as having our industry partners who are providing overall guidance. And at the end of that tool development process and the evaluation, people said, this is really good, but we'd like something that was more automated, that in essence that the hazard banding codes would be immediately implemented for you, versus you having to go and find them from a table. And so from that, we developed 2 spreadsheets. One that was there was a mirror version of our paper version that allowed for 10 chemicals to be assessed, and then one that was allowed an unlimited number of chemicals to be assessed in terms of how hazardous these chemicals were. And so and so again, at the end of sort of going through the evaluation of this, the workers and workplaces said, hazard assessment is really good, but we'd also like to do risk assessment. And so from that, then we developed a further version of a spreadsheet that what we're calling CHAP risk, and that's something that I'll demonstrate a little bit for you later. But one of the key things that we were trying to do was not really, it wasn't to reinvent the wheel. So we weren't trying to develop a system or a way of doing this, because basically when we looked out there was a way of doing this already. What was hazard banding? What we were trying to do was, as the title of this webinar was about knowledge translation, and how can we translate that knowledge into effective tools for small businesses to be able to use. And so that's really what our goal was really around that knowledge translation and the development of as simple to use tools that we could. And so all of these tools are available from our website, and for download for free use. And as I said, hazard banding, or what's also called occupational exposure banding, is the basis for our hazard assessment approach that we'd use. Just some background on hazard banding. These are some quotes from a NIOSH document that's associated with their occupational exposure banding tool that they've developed. They say that hazard banding is a systematic process that uses qualitative or quantitative hazard information on selected health endpoints to identify potential exposure ranges. And the way I'd sort of describe it is, as it says in the second quote, it's really, I see it as a screening approach that can provide you with a quick summary of the important health effects, and to really be able to identify hazard levels, and to be able to put chemicals into a specific hazard level, and that then helps to prioritize the chemicals and prioritize control measures, particularly substitution or elimination. And again, this is really a supplement to for occupational exposure limits. So if chemicals don't have exposure limits, then this is one approach that is quite robust and is able to give you an assessment approach that is evidence-based. Okay, so just to give you an example of hazard banding, and there are a number of different approaches for hazard banding. The approach that we've adopted is an approach that was published by a group called the lead author was their last name was Unknown, and so this Unknown et al. Paper from 2015 was their approach for hazard banding is the one that we adopted. And so basically we're under the taking information from the hazards identification section of the safety data sheets and then pulling that together to then produce a hazard band, or what we're calling a hazard level, because when we worked with workplaces, they sort of got a bit confused about the term band, so they like the term level better. And so it's basically being able to give each product based on their safety data sheet a level of hazard from A, what's lowest hazard, to E, that's highest hazard. And so what we're doing is we're going into the hazard statement section of the hazards identification section of a safety data sheet. And then what we're doing is, here we go. So what we've got here is we've got the hazard statements from this hazards identification section. And what we're trying to do is turn these into one of these hazard bands or hazard levels that is one level that describes the overall hazardous nature of that substance. And so what you can see here is there's a series of statements, and these statements are all supposed to be consistent across the world under the globally harmonized system of chemical safety management. And so, but there's three different types of statements. One is one set of physical statements, one set of health statements, and then the last set are environmental statements. And so the focus of hazard banding is really on the health statements. And the way that this process that Unknown et al. Use is that you take each hazard statement, and then for 4 different routes of intake, they have a hazard level. And so you basically you match up the hazard statement to the hazard codes that are provided, or the hazard band levels that are provided. And so what I'll do is just show you how that you for each of these hazard statements, there's a series of codes. I've put the rest in here under this framework. Any of the physical hazards or environmental hazards are grouped together, whereas the health hazards have specific codes for each statement. And so then you basically fill it out, and then you get the what is the overall or hazard level for each uptake route, what is basically the highest hazard level. So as I said before, A is the lowest and E is the highest. And so for across these routes of intake, you've got a C, C, B, and a C, and that then drives to what is the highest level there. And so this is a hazard level C chemical. So this is a way that this approach is sort of taking information from the hazard statements, pulling it together, and creating a hazard level for that chemical or product. And so there are a series of or a range of hazard and risk assessment tools out there. There's the tools that we've developed, and whereas our tools are really based on what other people have done, but we've tried to develop them in terms of what the industry sectors that we've worked with have said that it's important for them. And a key aspect of that is having a tool that is available in easy to use software, and it's software that they can keep on their own computers versus having something that they have to go to the internet to use. And so that was a key criteria for us, was develop something that is able to be used in-house and versus having to go outside, as in going onto the internet to use. The other key ones out there, there's Cosh Essentials that you probably would have heard of, and that we've based a lot of our work on as well. There's something called Stoffer Manager, which is a widely used one in Europe. There's the Champ from Chemscape, and I think that they'll be talked about that in a little bit later. And then there's a series of other ones out there as well. And so what we tried to do was, once we developed our own tools, was just to sort of say, well, how do our tools match to the other tools out there, and try to understand how usable they are. So usability is how easy is it to use the tool, and then in terms of utility, utility is basically does this tool or resource help you achieve your outcome. And so we did a process of assessing 5 hazard banding tools, the 2 versions of each app, the NIOSH tool, Cosh Essentials, and then the Stoffer Manager tool. And what you can see here is for 4 different chemicals, these are the hazard levels that came up from each of these tools. As you can see, the NIOSH tool really was more conservative, whereas the CHAP and the Stoffer Manager are pretty similar, as is the Cosh Essentials. And so what we found was that all tools really allowed people to achieve their goal of determining a hazard level, but based on the features, certain tools were easier to use than others. And so what this is really saying is that there are a range of tools out there. They're all good. They all will help you achieve your outcome, but some can be easier to use depending on what the outcome you're looking for. And so from our perspective, we then developed our new tool called CHAP Risk, where we took our current CHAP tools, what were focused on hazard assessment, and we were able to get a grant from WorkSafe BC to develop this tool where we looked at added to the hazard assessment, we added aspects of exposure and risk assessment, and then provided some information on or direction on control measures. And so just to give you a quick overview of what this looks like. So this has got a series of screenshots of the tool. And so this is the starting page. And so basically it's just an introduction page. It gives you some details about the tool. You would click on the start button. And then this is what we call our scenario page. And so this is where you would go in and say, well, what scenario am I trying to make an assessment about? And this could be for your overall workplace, or it could be for a specific part of a workplace or a specific product line. And so here you just add in your details of your scenario, and then you list the chemicals or products that you want to do an assessment of. And you just list them in this table here, and then you go to the next, you hit the next step. And this is where you'd actually do the assessment. And what you can see here is this is the overall assessment page. It looks a little bit complicated, but I'll step you through it. Basically, all of the chemicals that you'd listed in your previous table are here in a drop-down menu, and so it's a 7-step process. The first 4 steps are all around the hazard assessment, and steps 5, 6, and 7 around the exposure assessment, and then that drives you to a risk result. And so basically you identify the chemical you want to do the assessment of based on the ones that were inputted into the previous screen, and then you answer the questions of does the safety data sheet have physical or environmental hazard statements? That's a yes or a no. Then there's a question around acute toxicity that we provide some information about. And what we've done is we've got a little information bars here. So these provide the directions on what to do and how to do this. And so it's a yes or a no for each of those. And then you come to your hazard statements or hazard codes. So basically under the safety, in the safety data sheets, the hazard statements could be just listed by statements, or they could also include their hazard codes. And so if it lists hazard codes, people often find it's easier to use those. And so we have a drop-down list of hazard codes, or we've got our hazard statements. And so basically you find each of those, you click on them, and then you add them to the table. And what you'll see is, you're either using a hazard code or a hazard statement. You click on that, it adds it to the table, and you keep adding them until you've listed all your hazard statements or hazard codes. It then comes up with a hazard level it calculates that for you. So instead of you having to go and find those codes, it calculates it all for you. And so this is really your hazard banding aspect here on the left-hand side. And then we add to that some basic exposure assessment pieces that really have come from the COSH Essentials approach. And so this allows you to look at either liquids or solids. And if it's a liquid, we're asking for information about operating temperature or boiling point. And based on that, it gives you a rating for volatility based on this graph over here. So it calculates the level of volatility of the substance. And then, or if you have a solid, then we're asking you how dusty is that solid? Is it a low, medium, or high level of dustiness? And we give some guidance on that. Once you look at how it's released into the environment, you say how much you use, and then those two combine using this matrix here to give you an exposure level. And then based on that, the risk matrix will come up, and then the risk matrix can change if you're using the product more frequently. And so basically these pieces come together to give you a risk level, as it shows here, and that risk level is linked to a specific control approach. And so once you do that, you send it to the summary sheet, and what you'll do is as you do each chemical, it will come into the summary sheet, and you'll get ultimately a listing of hazard levels, exposure levels, and risk levels, and recommended control approaches for each chemical. And this then allows you to be able to say, look at which chemical or product is the most hazardous, or which is the most risky based on the way we're using it, and also some initial guidance on control measures. And so we have the last page is just an information page on what do some of these things mean, what do risk levels mean, some guidance on controlling risk, and some guidance, general guidance on control measures. So basically you can see that this process allows you to really provide come up with a prioritization or a listing of hazards, exposure, and risk levels that are based on reasonably simple inputs. So then, through this process, we because we're using safety data sheets a lot, and we're asking our workplaces who are trialing the tools to use the safety data sheets that they had. What was really clear was that a lot of workplaces found using safety data sheets very difficult. And so what we wanted to do is say, well, if safety data sheets are their primary role is to communicate hazards, we wanted to find out, well, how effectively are they doing those using some sort of objective approach? And so we've done a study looking at what we call suitability and readability of safety data sheets. And so suitability is in broadly defined how well the materials fit the target audience. And readability is what is the reading grade level someone needs to have, what sort of education level do they need to be able to read the information effectively. And so we did a random selection of 48 safety data sheets from the CCOHS safety data sheet database. And just to sort of highlight the results of this across different categories of what we call our suitability assessment of materials tool. We had an initial tool that is the standard one that's used across all tools, and then we generated our own modified tool to be more focused on the technical nature of safety data sheets. And I suppose overall what we would say is that in the area of literacy demand, the safety data sheets really perform really poorly as deemed to be not suitable for the audience. And then if we look at reading grade levels, there's a series of different indices that are identified here. You might have heard some of these. They say the smog index and gunning fox and fleisch Tenkate. And so these are showing what reading grade level these indices say that someone would need for different sections of the safety data sheet and the whole document. And what you can see is the assessment is that a reading grade 6 is really the recommended reading level, and you know across all of the sections and the tools across all of the safety data sheets, they're way over that. And so really what we'd say is, safety data sheets are really highly technical. They have very regulated content, but that one of the drawbacks is that they're trying to communicate to a broad range of audiences. And so in some ways, they're really then a poor communication tool for what I would think is their key audience, what are workers, particularly workers who have lower literacy skills. And one of the key things that we found was that there was quite a lot of inconsistency between the sections of the safety data sheet. So in essence, what was discovered or what was discussed in the hazard identification section was either not aligned or contradicted to what was discussed in, say, first aid measures or toxicological information sections. And so that really places a lot of confusion for workers when they're trying to, if they actually do take the time to read these. And so what we would say is that, and then part of this process, we looked at what training workplaces had for their workers. And most workplaces said they did basically generic WMIS training. Whereas in essence, WMIS is sure there's generic training, but it also has to be very specific to the workplace so that workers are able to know what are the hazards of the products that they're actually using and what to do if someone is exposed or in a first aid situation or in other emergency situations. And so really what we're sort of what I would say is that safety data sheets can be used for these three key purposes: for providing sources of hazard information, a resource for developing safe work procedures, as well as part of worker education and training. And the way we sort of see it is that tools such as CHAP Risk and the other hazard banding tools can really play a role in helping to contextualize safety data sheets for the specific workplace by either, say, the hazard levels help or give workers a easy to understand rating of how hazardous a product is. The hazard and risk levels can help you focus on the most hazardous or risky products. The risk levels can help if you're using a tool that does risk assessment, can help focus on safe work procedures on the most risky tools, risky products. And then there's a role for training and involving workers in the training in terms of using these tools and the use of these tools as part of WMIS training. It really we've found it really helps improve understanding of products that workers are using. And so overall, what I'd say is that what we've found is that there are a range of benefits for using hazard or risk banding tools that in terms of improved worker and employer understanding and engagement of workers and better management of chemical safety within the workplace. So that's all I was going to say. Thank you very much. I've probably sort of said too much already, but hopefully that's scooted through that. But thank you very much for your time, and happy to take any questions.
Thanks, Thomas, and thanks, Kevin. You can hear more from Thomas, and I asked Kevin to throw in the Workplace Health Without Borders doing a session next week as well, and so you can hear more from Thomas and a couple of other speakers on that control banding session as well. So thanks, Kevin. And having used, Eva mentions that having used the chat tool before, this one does seem more user-friendly, Thomas. So very nice feedback for you there. And Kevin mentions, of course, we've been, Kevin and Krista and a few people on our control banding working group, I shouldn't name people, have been working very hard on this with one of our projects as well, and giving a link to assess the compliance of the SDSs. So are there any questions from the audience? From folks? Before we, and we get to build on this with Angela coming up as the next, oh, sorry, Kevin.
Yeah, I just wanted to make a point, that it's kind of a question to Thomas as well, about how important it is to have a compliant safety data sheet. You know, you might have a non-compliant safety data sheet, do the assessment, and end up getting the wrong information because the information isn't right in the SDS. I don't know if you had any thoughts on that, Thomas. I did put a link in the chat box. There is a WMIS portal that you can go to that you can actually assess this SDS using this checklist.
Yeah. Thanks, Kevin, for that question. Yeah, definitely. You know, the issue of compliant safety data sheets and safety data sheets that are compliant to WMIS 2015, and having safety data sheets that are up to date is a really important one. And you know, definitely for any of these tools, if they're using information from the safety data sheets, if that information isn't accurate, then it sort of undermines the use of those tools. But you know, and that's, you know, something that's it's sort of like, well, in some ways you've got to start somewhere, but you'd like to think that the safety data sheet is an accurate starting point. But you know, what we've found with using or working with the various workplaces and the assessment that we've done of safety data sheets, so that they definitely can be a mixed bag in regard to sort of particularly inconsistency across sections, and also inconsistency in terms of using those standardized hazard statements as well. So yeah, it definitely that's that aspect of garbage in, garbage out. But yeah, I suppose it's sort of really highlighting the really important role that safety data sheets do play, and that I think there's a lot of work there to do still with trying to improve safety data sheets, and with in terms of them being a hazard communication tool for workers. I think they do a good job for people who are you know, more highly trained, but when it comes to workers, I think they're really overly complex, and that's that aspect of having such a wide audience that they're trying to meet. And so is there a way to sort of bridge that gap? And that's something that we've been thinking of a lot, and we don't have any answers yet.
And really good points from both. And it's funny, we're trying to find ways to make all this simpler in this, to introduce control and exposure banding when we don't have this information. But then when our finding is that our building block to know all this through hazard communication is our very familiar WMIS and our SDS, and then we can't, you know, we're finding issues with the foundation, right? We're trying to build the accessibility and we're finding issues with the foundation. And Lawrence, thanks, the biggest problem is mentioning about proprietary ingredients or undisclosed ingredients. And even though they can talk about hazards, it's really challenging, and to muddle through all that. So I'm going to move on, I think, if it's okay, to Angela now, just because we're and she's going to pick up on this whole whole topic. Thank you, Thomas. Can't thank you enough. Everyone go check Thomas out next week at the Workplace Health Without Borders session as well. You can build on, oh, I'm looking for your bio. Sorry, I'm stumbling here. Sorry, I got off track, Angela. So thanks again, Thomas, and hopefully people can check out the webinar with you next week as well. So welcome, Angela. You can share your screen. Our next speaker is Angela Wheeler. She is has master's, a CIH, a CRSP, and she's an SDS registered author. So we can pick up on this subject matter with Angela. She writes these babies with over 20 years of EHS experience in various industries across Canada and the US. And as the program manager for the CHAMP software at Chemscape Safety Technology, she works with clients to efficiently generate these risk assessments according to hazard and control banding principles. I'm going to talk to us a little bit about the examples using welding as well. So over to you, Angela. Thank you.
Thank you. Thanks so much for inviting me and allowing me to speak on control banding. You're right. I'm an author, and I share your pain. I don't author so much anymore. We have a side group that does that, but I analyze them a lot, and I put a plug-in for the AIHA registry for the authors, SDS authors, as often as I can. And I guess the hope that I can give you, or share a good part of that, was as a company that tabulates and takes all the information, or main points of a SDS, we see an update of 30%. Our SDSs, 30% of them are rotating, being updated on an annual basis. So yeah, it's hard. It's good to hear that people are getting to it, and so the farther we get with GHS and the more versions, up-to-date versions, the better those SDSs will become. And we believe that involving the workers and putting proper controls in place will protect workers sooner than mounting extensive sampling campaigns, which is typical of us IHs, and myself included. So I hope you, oh, look at this, it's going to be temperamental. There we go. So control banding, and you'll see some repetition here between Thomas and I, and I'm hoping that it means that you'll come away even more familiar with our terms and the way we slice and dice hazards. So control banding is a validated risk assessment method commonly used to evaluate chemicals. It's a 20-year history, starting with pharmaceuticals and chemicals, more recently into nanotech and ergonomics. Control banding is used internationally as part of as Thomas pointed out, the ILO, International Labour Organization's chemical toolkit. In the UK, the Health and Safety Executive has COSH Essentials. I invite you to take a look at that. In North America, we use control banding for asbestos abatement and when working with crystalline silica, which you'll see later. NIOSH, as Thomas points out, acknowledges control banding can be a useful tool for small businesses, but that's a bit restrictive. It was originally designed for the small and medium, and as he points out, so many of them out there, and they lack industrial hygiene support. So, but we've seen some of our clients are large businesses, and they use this tool as a force multiplier for their health and safety teams. So we're all working as hard as we can. Just there's so much to do as industrial hygienists. Control banding offers a time and cost-effective way to assess risk and determine relevant control measures to reduce exposures to workplaces when OELs and exposure measurements aren't readily available. Sometimes you don't have the hundreds of samples to work with. There we go. So this is our hazard chart, and this will be available to you. Just beautiful, colorful, I should say. We give this to all our clients. They post it in their break rooms so that the workers understand the hazard banding process, and they can really pick up on the levels A, B, C, D, E, and how they relate to their health. So first step, as Thomas said, is to sort the chemicals into hazards. This way we can focus our control efforts on highly hazardous substances, those that cause cancer, mutations, occupational asthma. And as you can see by the chart, GHS classifications make this easy. High hazard chemicals are the top, hazard band D and E. C are corrosive, less toxic, and then B and A are least hazardous and the reversible irritants. Here's my cheat sheet for anybody not using a tool, such as Thomas's or Cautious Essentials, things like that. We our computer does this all for us, and then ranks each chemical by its highest hazard band. Here you can see the GHS symbols and signal words used to prioritize your control efforts. Any SDS or label with a star man, you need to have a plan in place to avoid worker exposure. The difference between E's and D's is that E's are carcinogen category 1s, highest category, highest level of carcinogens, and they're mutagens and respiratory sensitizers, whereas D substances are the less hazardous category 2 carcinogens, and then they get into the reproductive toxins. Anything that is identified as fatal is also in the hazard band D and signified by that poison pictogram. For hazard band C substances, you'll find the corrosive pictogram. You also see words like toxic and STOT, single target organ toxicity, a body system rather than the whole body toxicity. And then again, A and B are the least hazardous and will present only with an exclamation mark. I hope that helps you. Again, this is something that workers can get their heads around. So we, once we've ranked all those chemicals by hazard, we organize control measures into ranges or bands. From the bottom up, we've got general ventilation. Again, we do icons. That's our thing. It helps the message get across and brings it down to the worker level. Bottom to top, general ventilation, low risk, local exhaust ventilation, medium risk, containment is high risk, and then seek expert advice, which is extreme risk. It's important to note that each control band builds on the previous bands, so that a control band 4, extreme risk, expert advice, includes the exposure controls from containment, local exhaust, and natural ventilation, PPE, and good IH practices from all the way down to control band 1. And I'm going to go into the details just quickly from each of the bands. Here is control band natural ventilation. Jumped ahead. Icons work as visual summary, as I said, and details are we pull from the Cautious Essentials. That's the Health and Safety Executive out of the UK, and their technical documents. So approach one, control band 1 is appropriate for low risk activities. Prescribes natural ventilation as it is unrestricted access to fresh air, clean air flowing across the breathing zone, 5 air changes per hour, good IH practices such as prompt spill cleanup, processes in place to train and ensure exposure control measures are known and used. And also the standard PPE such as coveralls, safety glasses, and gloves would fall into that. Control band 2 is appropriate for medium risk activities, prescribes the previous measures plus controls designed for the task. LEV with 0.5 meters per second at the contaminant source, exposure of the contaminant if possible, enclosure, annual testing of that local exhaust ventilation using a ribbon smoke anemometer. You get that idea. Control band 3 is appropriate for high-risk activities, prescribes all the previous measures plus material handling performed in closed systems with limited breaches, negative pressure if possible, venting to a safe area, work permits to open the process vessels, containment or isolation of workers, and chemical tasks. Control band 4 is where I typically get pulled into, appropriate for extreme risk activities, prescribes multiple control strategies, exposure control plans. Often respirators are used, and that makes medical fitness necessary. Some hazards like lead, asbestos, silica may require health surveillance of workers. Preventative maintenance programs are also part of this control approach. This is our risk matrix showing how those risk levels correspond to controls necessary for tasks. You saw it in one of the, also it lines with Thomas's tool. You can see, excuse me, hazard type along the left-hand side bottom. and then irritants up to carcinogens. Then the exposure profile along the bottom, small, medium, or large quantity, as well as volatility and dustiness. Again, this aligns with COSH Essentials. We didn't make this up. This is being used quite extensively over the years. But the visuals and the risk assessment is how we put together. You can see how low risk is green. That area applies to hazard group A and small quantities of hazard group B. The yellow boxes show medium risk, with LEV as the control measures for significant exposures. Risk categories necessitating containment are that orange and E. All E is requires significant. There are significant exposures and require containment and exposure control plan. Here, I want to simplify it again for you guys. We like to make the case for sharing chemical management within the company. I challenge you to let your supervision assign and oversee the proper controls for control band 1, low risk. This would typically be minimum PPE for a work site. Likewise, field health and safety personnel should have the authority for group hazard band control group 2, and hazard bands interchangeable. The medium risk, this gives the site more ownership and efficiencies, right? They can move ahead with their controls a lot faster than having to get corporate involved, leaving the high and extreme risk exposures to your highest level of health and safety resource. And they'll develop plans and those multiple control strategies. So now using welding as a practical example of control banding, we use welding as for welding and thermal cutting, often thought of as an activity or task that occurs across many different industries like painting and abrasive blasting, tasks where the source of the health hazard is within arm's reach of the worker, within 30 different welding processes in construction, fabrication, repair. Welding is considered an industry itself. Welding also presents a highly variable exposure profile, includes process and task, the base level, the base metal to be welded, any filler metal or flux. Added to that, the differing human factors, body position, eyesight, habits, craftsmanship, or experience are all part of that exposure profile. Welding environment also creates variability, including the size of the task, the configuration, dimensions of the work area, ventilation, confined space, moisture, and then the simultaneous operations, all part of that. Very quickly, the air contaminants of concern for welders. Their welders are at high risk for exposure to welding gases and fumes, but everyone who works near that welder can also inhale welding fumes, especially in confined spaces or indoors where fumes can't escape and the hazard levels can accumulate. In fact, workers who work in the enclosed or confined space with a welder can have the same level of exposure as that welder. Some of the health effects of welding, probably all know these. Short and long-term health effects attributed to welding, most notably welding fumes in general, not just hexachrome, beryllium, or cadmium component, have been classified recently as IARC human carcinogens. That said, control band 1, natural ventilation, is not appropriate for carcinogenic welding fumes. However, engineering controls such as local exhaust ventilation can reduce fume exposures if used correctly. That is, positioned 1 to 1.5 foot diameters from the arc and routinely measured for effectiveness. Key area. LEV should be part of the solution, but not a basis for a control approach. Remember that this level applies to potential carcinogens with low quantity and fume emission. So TIG welding, for example, one of our low emitters. Even if LEV does not eliminate welding fume at the source, it can enhance natural ventilation to reduce fume exposure to coworkers in the shop or immediate vicinity outdoors. Control band 3 and 4 are what we need to have for welding exposures. Containment of the process is where emissions are captured at the source. The containment needs to create a negative pressure at the source so that clean air moves into the contaminated zone This scenario is ideal, but may not be practical or available outside of dedicated state-of-the-art manufacturing facilities. Containment of the worker is another way of protecting welders. In this type of containment, the worker is surrounded by clean air under positive pressure, like an isolation room. Most welding necessitates the worker being within arm's length of the work, which makes the isolation room unrealistic. However, isolating the worker's breathing zone is not. Use of powered air purifying respirator is intended to create a containment level of protection for the welder during the welding and thermal cutting process. Because the use of the APR is not true containment of the contaminant, this control scheme must include protection for the other workers, contractors, visitors, increased ventilation or LED, restricted work areas, so keeping people out of the work zone, decontamination practices, and PPE are also part of that control scheme. Here is my, as part of the AIHA welding book update, we have provided an RP strategy for welding, and it's part of our call for culture change in the industry, and so we presented this. Welders are being exposed to carcinogens daily, so simplifying the exposure to increase adherence is key. You can see that we've separated the exposed population into two groups and the exposure into two categories. Control banding reduces the exposure control into 4 approaches. So high fume emitting processes, the welder and welder helper require a PAPR with a CAPE and a HEPA filter. High fume emitting processes for coworkers and bystanders in the shop or immediate vicinity outdoors require half-phase air purifying respirator with a P100 filter. Low fume emitting processes for the welder and the welder helper require a half-phase APR with 100% P100 filters, and low fume emitting processes for coworkers, bystanders in the shop, or immediate vicinity outdoors require an N95 respirator. So control banding provides valuable device, but is not a complete replacement. This is our disclaimer, right? Not a complete replacement for experts in occupational health and safety, nor does it eliminate the need to perform exposure monitoring. The control banding results may need to be reviewed by an adequately trained personnel and properly installed, maintained to keep the worker exposure within acceptable limits. Periodic monitoring is also required to check the control methods work as intended. Here is more information. I hope I have inspired you to learn more about control banding. Give it a try in your organization. Here are some tools we recommend. Again, our hazard banding chart is available. We have a newsletter. The updated welding guide is available at the AIHA site. Here we have cost essentials guidelines sheet, very effective at figuring out the best control for your appropriate. Then I'd also like to call out, real shout out for that the Health Essentials, the HSE Breathe Freely tool. This is a free tool and it gives you control advice for welding with 4 easy questions. And then they have guidance sheets that go with that too. Thank you for the time.
Thanks, Angela. Do you want to, I'm going to pop the, or Kevin, you can, the Breathe Freely tool in the chat session, but I wasn't sure if you were going to pop it up. We still have a couple of minutes and we have questions for Angela if people have in the chat window. And Jennifer, feel free to shout out here while we look for the link. And I think, thanks, Angela, you're going to share that Breathe Freely tool. Oh, excellent. And feel free to write questions in the chat. There's been a lot of helpful links information. Thanks, Kevin, for helping pinch hit on the info sharing. Yeah, please, you can unmute your line. You can write in the chat. We do have a few minutes for Angela, and this is the Breathe Freely tool. We, it's so funny. Thanks, Angela, for saying this. So what this whole session is trying to get people to, and it's tough. We're from an occupational hygiene perspective, and we're all hygienists. The world of hygiene, you know, we're trying to kind of put it on its, look at it from a different lens in terms of we have to control these hazards. So we're exposure assessment, but we're recognition, assessment, control of hazards experts, and it's a tough haul sometimes when you're saying, oh, you know what, don't spend all your money on hygiene assessments. But that's what we want to say, and as control, and that's what we're going to show with, you know, some of the tools we're providing. And thank you for showing the Breathe Freely tool and the CHAP tool. We want to look at what we know and control hazards from people being exposed to hazards, and mobile operations, people who don't have the money to do the hygiene assessments, people like, we have to do something, and that's what the Silica tool is all about. So thanks for showing that. It's pretty simplistic, but it's powerful to do something. So let's all commit to doing something when you can't do hygiene assessments. Any questions for Angela? Angela and Chemscape and Mike Phibbs, we've asked them here because they helped write the Mike Harris manual, welding manual. There's a new chapter in there around control banding. So we really want to highlight some of that work and show how, when things are complicated from an assessment perspective as well, this can be used, especially when we don't know how hazardous chemicals or exposures can be. We still have ways to control. So quiet group or questions. Anybody have anything for Angela? Okay, well, Angela, we're gonna move on to thank you so very much. And Mike will be talking, I think, at the Workplace Health Without Borders session as well. So just if people want more from hear about control banding, we've got more for you. So I'd like to invite Ella. Are you here, Ella? Oh, sorry, Terry.
Yes.
Are you?
I am.
Okay.
Terry was going to go first, but I can go if he's not available.
Oh, I mixed that up. Geez, I'm getting tired. It's last week. Terry, yeah, over to you. Todd, are you here to introduce Terry? Todd has been working with Thierry, and I wanted to have him introduce because we wanted to bring you the. So yes, we did it in this order. We promised back when we kicked off the session to talk about the Silica Control Tool and the exciting news that it's coming to Ontario. And rather than stats and this and that, and we thought, let's show the user experience. So with our pilot program that happened over this past year. So I wanted Todd to introduce Thierry because he's been such a fantastic user of the pilot program, and hear from a user perspective. And again, stating ahead, none of this is perfect science. It's again designed for those who are doing nothing to help us control exposures, to reduce exposures of these hazardous materials to folks and the workers, right? So over to you, Todd, to introduce Thierry. Thank you.
Okay, thanks, Kimberly. Yeah, Thierry Belisle is a technical advisor, Occupational Health and Safety for Public Service and Procurement Canada, otherwise known as PSPC. He's been with that department for 2 years now, and he provides advisory service to managers within the organization. His main portfolio includes the trades that do the building maintenance of assets owned by PSPC and Parliament Hill. Specifically for the silica exposure, he has been working in close collaboration with the Heritage stonemason team to find appropriate dust control strategies. And at OHCOW, we've been working with Thierry and other members of another acronym, PSAC, that's the Public Service Alliance of Canada, which is the union that the tradespeople belong to assess the silica exposures and advise on the use of this Silica Control Tool that Kimberly mentioned that Thierry's going to give us a demo of, in addition to occupational hygiene monitoring and medical surveillance for the exposed workers. So Thierry, I'll turn it over to you.
Thank you, Todd, and thank you for the introduction. I'll just quickly begin with a short presentation, maybe a bit of context for everyone here today on how this collaboration happened. So this is just a quick PSPC use case, how we've used the Silica hazard control tool, and then I'll finish with a quick demo of how it actually works. So context, I think Todd mentioned it, PSPC mandate includes the maintenance of many federal buildings. Some of you here may know us by our previous name, which was Public Works and Government Services Canada, PWGSC. Our main occupational group exposed to silica are the heritage stonemason. So they take care of the masonry work for many of our heritage building across the national capital area. Some of it is done in-house, others projects are contracted out, but they do a lot of the maintenance on our buildings. We also have the Dominion Sculptor team, which is a newer group, less employees, and their silica exposure is mostly from like stone carving, stone cutting activities when we need to either restore some past sculptures that are on Parliament Hill or in any of our building. We've done some recent air sampling on our end in an indoor environment, which demonstrated high generation of silica for stone carving activities. On that specific case, the masons were working with a stone that contained up to 90% silica content. So you can imagine how easily it is to generate high level of silica exceeding the allowable exposure limits. Through that and through collaboration with PSAC, as mentioned by Todd, which is the union representing the trades, we contacted OHCOW for support and guidance on industrial hygiene. We had some brief discussion about what could be done and certain things, and through that, OHCOW asked us if we would be willing to participate in the pilot program for the Silica Hazard Control Tool, which is a very neat online tool, simple to use, easy interface to create exposure control plan, estimate exposure level for various construction activities. So for us, and me specifically, it was very good for the heritage stonemason, because even if they do heritage work, it's mostly construction activities. The initial use was to build an inventory of all the tasks that generate silica and their associated exposure. So grinding mortar, cutting stone, drilling, concrete drilling, coring, all kinds of tasks are all included in this tool. So I started to generate an inventory and their exposure. My second use through that was to find additional control measures and their effectiveness at reducing exposure. So as you're working through the tool, it will suggest you some engineering controls and other control measures that you can put in place as an employer to further reduce the exposure of your workers. And it was this kind of something I was not expecting through the tool, but it gave us some great ideas on other options to explore. And then finally, specifically for us, it may not be everyone that has the capacity to do this, but it was a great tool to validate some result that I obtained, well, that we obtained by doing some task-specific air sampling. So for example, what is the exposure level for an employee who would be grinding mortar in an outdoor environment? I did, well, not I, we did the test ourselves, but we also had the data from the tool. So you can see at the bottom left of my screen, this is the expected exposure for mortar grinding outdoors, specifically for tuck pointing, without any sort of engineering control. So just the base level of risk, which is quite high. You can see at 1.682 milligram per cubic meter. For the exposure limit in Ontario, we're far exceeding the allowable level. I think we're about 16 times the exposure limit. So higher than what you could be allowed to work with a half-face respirator, for example. If there are any federally regulated employer, you might see that our exposure limit is a bit different. We're a bit lower at 0.025. But this is something we take into consideration as I'm using the tool. Finally, we can see at the right side, which is the mortar grinding outdoor, this is the exposure analysis with control. So the tools allow you to do both. So as you're working through the process, you get the exposure level without control, and then your final result based on the measures you've identified. This here is just a very brief risk exposure assessment I completed. All I want to show is basically the task: mixing mortar, carving stone, coring and drilling, chip hammering, and you can see in the intensity of exposure, these are just some data on the expected dust generation for these tasks, and all of this was taken from the Silica hazard control tool. It was just a great option, like a great and easy solution to find out the exposure level of different activities. Before I move on to doing the demo, just some quick conclusion. It's a great tool for employers to do their initial hazard assessment and expected dust generation. It's very easy to use. As Kimberly was mentioning, for employers that may not have all of the resources to do industrial hygiene studies, it's a very great option. It's useful to identify control measures and dust suppression techniques. So if you're wondering what you can do to further reduce the level. Some things I noticed I've actually mentioned through the pilot program, that's why we do these, is you cannot combine engineering controls in the tool. You can combine them in real life for the worker, but in the tool, you cannot combine engineering control to see what your exposure level would look like. And then finally, it supports only one activity at a time as you're doing a Silica exposure control plan. Meanwhile, when we do masonry activity, it's usually a sequence of steps. You would have the mason do a relief cut in the joint, and then they would remove the rest of the mortar with a chip hammer, and then they would do some mortar mixing, and then the repointing. And so what I did is I did these tasks individually in the tool and then put them together, but it would be neat if you could do the sequence of steps.
Thanks, Thierry. And just as you're pulling that, I just wanted to mention again, thanking you. So Thierry wasn't our ideal user in that, he knows a lot. He's pretty versed in this, and we think he's one of the worst case scenarios in terms of exposure, as he mentioned, just on the type of material he's using. So remember the tools, if you remembered Melanie Gormaning and Hugh Davies, over the few years that we've been here at October talking about the tool, it's really based on exposure data from literature and from from what we have. It's got good guidance in there, but we think that Thierry's scenario and from the workers is a really high material that they're working on, and they're therefore kind of a worst case scenario. But I just did want to mention that while you pull up the tool to show us more, and thank you again. I meant to say it's not the ideal candidate because we want to know how accessible it is to workers, to unions, to health and safety reps. We want, and I think Thierry's going to show you that it is accessible to that. It just happened to be that he's done an awful lot of crunching with it, and he's learning a lot from it. But I think he's trying to tell us that it's quite accessible. He's very knowledgeable. You want someone who's been using it a lot, and he's the guy. So thanks.
Thanks, Kimberly, and that's very true. I'm a technical safety advisor, so this is really in my field, but I showed it to many of the foremen and many of the mason, and they easily pick it up. It's just a natural flow, and they understand what it does, and it's been well received by the worker and some of the foremen. And as you said, we are a unique scenario because we work with stone, heritage stone that have very high silica content, and the same for the mortar we work. It's not necessarily the same composition as the mortar that is used in new builds today. Sometimes there's higher silica content. So yes, in that sense, we are a bit different. So thank you. So here you should be able to see my screen now. This is the interface that, as a user, you see when you log into the tool. At the top, you can see my name. On the left-hand side of the screen, you can see, well, it's test company because this is as part of the pilot project. But you can put your information of your company. You can put your logo. I did that on the right-hand side of my screen. And you can see exposure control planning. These are all plans that I have done in the past. As Kimberly said, I've been using the tool a lot and just generally learning with it. I've done many of them, and you can see all kind of activities: cutting marble, mixing, pouring cementitious material, coring and drilling, sweeping construction dust, polishing artificial stone, tuck point grinding, chipping concrete, all of that. And what I wanted to do right now is do one activity with you. Should take us about 5 minutes. I hope I'm still okay for time. Kimberly,
you're great. You're great. Yep, you're great.
Thank you. So I'll be going through it quickly, and you may not have the time to read everything that's on the screen, but I'll just generally let you know what is going on. So this is just the introduction. It just explains you the path that we will be following. So as a user, you can read the step and understand what everything means. So the next step is going for us or you as a user to enter your employer detail. And this is very important because at the end of this process, you're able to generate an exposure control plan. So a PDF document listing all of your control measures for the work site that you've entered. So these are just my general information for now. Then we're going to be discussing the silica process that we're doing. So what are we what are we assessing? This is the job site. In this case, I'll put an actual job site, 249 Wellington. Well, I'll put it here, and the job site is going to be just this building for us. In our case, this is an industrial, and it's a renovation. So I won't enter everything else, but you can understand, you can enter your job site here. Now, what is the activity we are going to be doing? For now, I decided to choose tuck point grinding, mortar grinding. So what kind of material are we working with? So you can see from the tool, there's various material included. In this case, I'll be using mortar. What is the task I'm going to be doing? I'm going to be doing some tuck point grinding. Just showing you another example, we could have chosen concrete. And then what are we going to do? We're going to break it. We're going to do some chipping, some coring, some crushing. There's various options. Like you can see the scroll, as I'm scrolling down, there's quite a lot. But in my case, I'm going to be doing some mortar tuck point grinding, and I'm going to be doing this with an angle grinder, so tuck point grinder in this case. What kind of work area are you going to be working in? Inside or outside? We often do inside work for winter projects, so in what I call enclosed environment, in a tarped environment, but let's say for today, this is going to be outside. And our workers are going to be completing a shift of about 4 to 8 hours of exposure. We never really exceed 8 hours of exposure just because of the setup and getting to the work site and all of that, so it's a bit more representative than a full 8-hour shift. This is just a summary of what we've entered. So now the tool is going to be generating our expected exposure level without any sort of control. So you can see we're at 1.9, almost 2 milligram per cubic meter. And you can see the estimated exposure exceeds by 1,989% the allowable exposure limit for Ontario. So we're far above the exposure limit without any kind of protection. So no PPE and no engineering control. So obviously we need to factor that. Then we continue. Now it's going to ask us about what kind of control measures do we want to put in place. In our case, we can't do elimination and substitution because it's part of our job to do the grinding. And then this is where it gets interesting. What kind of engineering controls will we be implementing for this activity? Wetting integrated to the tool, so like wet grinders, wetting separated from the tool, so sometimes we'll wet down the surface. For heritage work, it's a bit harder because they don't want to stain the zone. LEV integrated to the tool, so grinders equipped with dust shroud. And in our case, generally, we'll be using local exhaust ventilation separated from the tool. A lot of times the workers might be working with like mobile dust extractor or vacuums with the sufficient amount of CFMs and things like that. So let's choose that for now. And these are just general question on maintenance and other measures you can put. So yes, we will be completing maintenance. Yes, we will be cleaning the work site at the end of every shift. Will workers and PPE be decontaminated? Yes, usually we set up a decontamination area outside of our, like the scaffold or just next to the work site. Usually, have we trained our workers? Yes, we have. Exposure, emergency, let's just say in this case we do. Work shift, it's not something we generally do. So usually we won't have different teams taking over. We usually use barriers and enclosure when possible, so we can add all of that information, but you could say no, and it will be reflected in your exposure control plan. Again, just a summary of what we've entered. So you can kind of see, I hope I'm not walking through the process too fast, but it's just quite an easy process to walk through. So now, what the tool does is it provides, with proper implementation of control, the estimated exposure level. So it shows you the estimated exposure level after all of the controls we've implemented. Again, a lot of this is, you know, as Kimberly said, just great information for everyone. Just gonna finish here. The next section is about PPE. In our case, workers have respirators available. They'll often work with full face respirators. We also have a few powered air purifying respirators in stock, but not all industries may have access to these. Generally, depending on the task, we may be using Tyvek suit as a disposable coverall, or just the general coverall of the worker. Okay, so again, these are just things we can read through about legislative information for, I believe this is for the province of Ontario, a few other you know, information. Now, the interesting section for a foreman, for a supervisor on site, or for us, is the exposure control plan summary. So this is my summary of everything I've included so far, my list of engineering control, my list of control measures, my PPE to be used, and my final risk classification, for example, recruitment to proceed as acceptable exposure level or perform an air sampling test. In our case, we've done additional air sampling to confirm. And now, there you go. I have the capacity to generate my exposure control plan. You can see the little the picture on the left side of my screen. This is my plan. Oh, well, there you go. Oh.
That's awesome. And Thierry, I did want to, again, show how kind Thierry's been, because he's run us through this Ontario pilot. But we also gave Thierry access to the BC version, because they use the British Columbia, and which is the federal exposure limit for silica, and that's being worked on. As you know, there was a proposal to lower the silica occupational exposure limit, but Thierry, it's no problem to say, you know, he has folks. This impacts workers. People think it's a number in a book, but you know, Thierry is working with masons who then, you know, he's trying to explain, oh, well, yeah, this tool says you're compliant, but you work on the federal government site. So you actually are not compliant because your, you know, exposure limit's different. And it's tough for them. They're looking at the, you know, construction guys across the street and saying, well, they don't need the same kind of controls that we do. And we're trying to say that's the most protective, and the exposure limit's different. So this actually affects workers. It's just interesting to say. And I did want to also note that the exposure control plan that Terry was showing in BC, the printout from this is acceptable as a compliance. You know, it shows that you did the risk assessment. Again, this is designed for people who are doing nothing. But they've looked at something, a construction, a mobile activity, drilling into concrete, and they're available to, you know, as a compliance response. So yeah, questions for Terry? I see John Lee is asking, oh.
Kimberly, I'm just showing, so you know, I'm just showing the printout that you mentioned. So this is the end result, the printout. You can see this is something that the job site can carry or the workers can have available on site. And it's just a very simple and neat way to document all of the information we've included so far. So yeah. It's about 12 pages long. So thank you.
Yeah, thank you. And John's asking, yeah, it doesn't weight, John, the exposure. So again, it's about doing something. It gives you a general guidance, and it's based on literature and exposure data, about 4,000 samples in a linear regression model. So it's not hygiene. It's not a replacement for full-blown assessments. It's for people who aren't doing assessments. I hope that makes some sense. And yeah, Kevin, we're trying. So CCOHS might be looking at purchasing the Silica tool. We're starting with Ontario. We did the pilot with OHCOW. We're looking at it's coming to Ontario for construction, because right now that's what the data and the tool allows for, but there's work going on. Melanie and teams are looking at, you know, what other contaminants can we look at with this? Welding fumes. What other can we extend it to mining? Can we extend it to artificial stone? It's very close for industrial. Artificial stone, we know, is a huge hazard. So yeah, it needs to be there's work going on in that area and continues to go on to make it. But the good news is it's going to be made available in Ontario for construction workers for next year, we hope. And Eva, did you try both limits for the model? Oh, yeah. Yes, he did. I can answer for him because we're running out of time. Yeah, and yes, he was able to access some of that, and he's showing for us. Denny, are there statistics about the number of people using them? Accessory? Oh, yeah, no. No, Debbie, we don't have that yet. Still just we kind of dropped on that because it's coming, and that was our whole intent. Was we're now working on the work plan to bring it to everybody rather than worry about the whole. It kind of had its success story already, and we wanted to show that in the example today. Yeah. Any other? I don't want to cut Terry off. Oh, perfect. But go ahead, Terry, please answer in case I didn't do a good, we do have time. And then we'll, we want to try and fit Kevin in, but we'll introduce Ella. So go ahead, Terry, please verbalize if you wish.
Oh, sorry, Kimberly. I'm okay just responding in the chat if people have more questions, yeah.
Okay, and any other questions for Terry live or any comments from folks? Okay, wonderful. Well, thank you so much for sharing, Terry. Amazing work. And again, no nobody's trying to say the tool is perfect, and it's not a replacement for assessments and proper when people can do it, but it sure helped prioritize in Terry's case. And you know, he is having proper hygiene monitoring done, and you know, they will be looking at both of those. But it's a really great accessible tool when we can't do full-blown assessments. So thank you so much. And now we're going to move on to Carex Canada. So Ella is with us. Ella, if you want to go ahead and share your screen. Ella is a senior research associate at Carex Canada, and where her work has focused on creating and updating estimates of carcinogen exposures in the workplace. Her interests lie in occupational exposure assessment, the impacts of sex and gender on health, and the mobilization of occupational exposure in cancer research. Ella has an MPH in occupational environmental health from the University of Alberta, and I did want to make a shout out to Masood and Krista for helping review these tools from OHCOW that Carex Canada is going to show us. It's been, you know, it's always nice to collaborate. So over to you, Ella.
Thank you. And can you see my slides okay?
Perfect. Sorry, I muted too early. Yeah.
Okay, all good. Okay, great. Yeah, thank you so much for having me here today to present on eWork Online. I'm going to start off with just a few slides with an overview of Carex Canada and our occupational exposure estimates, and then I'll follow up with a brief demonstration of our newly launched tool, eWork Online. So Carex Canada stands for carcinogen exposure, and our purpose is to provide a body of knowledge about Canadians' exposures to carcinogens in the workplace, and we also have an environmental aspect. But through this work, we support organizations in prioritizing exposures and in developing targeted exposure reduction policies and programs. And one of our main offerings is our estimates that describe workers' exposures to carcinogens. We are hosted at the University of British Columbia, and we've been funded by the Canadian Partnership Against Cancer since 2008. Dr. Cheryl Peters, who's based out of BC, is the principal investigator. We currently have over 50 occupational exposure estimates to carcinogens that have been classified as known or suspected carcinogens by the International Agency for Research on Cancer, or IARC. Estimates are available by the variables listed here: occupation, industry, sex, and province. And where possible, we also have estimates by level of exposure, meaning where we have adequate data or the methods to create those levels of exposure. You can learn more about the methods that we use at the link, using the link at the bottom of the slide there. And I've also included a QR code there in case you want to take a quick snap, but it's all on our website. So just in this past year, we updated our estimates, which were originally created for 2006. We updated them to 2016 using the most recent census year. And this update involved a few different steps. So first, we conducted key informant interviews to help identify potential changes and priorities. We also reviewed the literature for changes in processes, uses, and policy that would impact workplace exposure. So for example, we found evidence of reduced CCA wood preservative use, and so we adjusted those proportions in our estimates. And then finally, we translated the estimates to a new coding system because the occupations and industries were coded using a different system in the 2006 census. And then note that just over the next couple of years, once the latest 2021 census data are available, we will be updating our estimates once again. Our estimates have been used for a multitude of reasons. So first, they can be used to raise awareness of carcinogens and the importance of reducing exposure. They can be used to identify high-risk populations and prevention priorities. So for example, they can identify what the priority exposures are for a given jurisdiction, industry, or workplace. Carex Canada estimates have been used to influence changes to programs, policy, and practice. And if you're interested in learning more about this, please refer to the reference at the bottom of the slide. And then finally, Carex estimates have been used to inform research opportunities. So they were directly applied in projects such as the burden of occupational cancer, which was led by the Occupational Cancer Research Centre and Paul Demers in Ontario. And this in turn has informed several policy impacts as well. So eWork Online, it's a tool for exploring our occupational exposure estimates for 2016. We just recently updated it and launched it in this past month. And this new version of the tool allows for improved customizable queries and also allows for more in-depth results than the previous version of the tool. The results show the number of workers exposed to the carcinogens nationally, by province, by industry, and by occupation. It can answer queries such as, what are the top carcinogen exposures in a particular industry, such as construction, or the carcinogen exposures for a particular occupation, such as carpenters, and also how many workers are exposed to each carcinogen in a particular province. And before I move on to the live demonstration part of this talk, I just wanted to outline a few different ways that you can connect with Carex Canada. So on our website, you can find a few resources. We have our carcinogen profiles, as well as our occupational and environmental estimates, as well as some other resources. You can sign up for our e-bulletin, which is a biannual newsletter that summarizes information on upcoming webinars and the latest happenings with Carex Canada. We also have Carcinogens in the News, which is a monthly digest of news articles, publications, government reports, and similar types of information related to carcinogens that we've classified as important for surveillance in Canada. And of course, if you have any questions ever, please feel free to reach out to us by email. And now I'll switch over to my web browser. Okay.
I see it really well, Ella. It's great.
Perfect. So this is eWork Online. You can access it on Carex Canada's website under the Resources tab. On this home page, you'll find just a brief introduction to the tool, as well as links to some resources that provide some additional information for you. So if you want to learn more about our occupational approach, you can read about it using this link. And then we also have a tutorial recorded about eWork Online, and it kind of walks you through the tool as well. But it is pretty intuitive to use, so I don't think you'll have too many issues. The main table here summarizes the total number of Canadian workers exposed to carcinogens in 2016. By default, the results will show by sets, and you might notice that the total number of workers exposed may not equal the sum of men and women exposed. And that just has to do with the way that Statistics Canada shares their census data. They introduce some fuzziness to the data for confidentiality purposes. And so that's reflected in our estimates as well. You can also view the results by exposure level where that is available. Some of the carcinogens have a little exclamation point icon beside them. And these are the estimates for which we use a different method or different data sources to estimate exposure. And we want to flag these because they are not directly comparable to some of the other estimates, within our database, because they use different methods and data. And also because these will not appear in the industry and occupation tabs of the tool. Because the estimates are available at different resolutions of occupation and industry, so we weren't able to fit it in there. Oh yes, and then if you click on it, you can read more about how that specific estimate differs. You can sort by any of the columns by clicking on the little arrow icons beside the column header. And then all of the tables in eWork Online, you can download by clicking the download button, which will be available in the top right corner of each table. If you are not able to find what you're looking for using eWork Online, we do have the complete data set available for download. It is more complicated to use. It's based in Excel, but it will allow for more complicated filters and more in-depth queries. But I think that you'll be able to answer most questions using eWork Online. And so now I'm going to move on to the industry tab, which you can access on the left-hand side here, or also just over here on the homepage. And so you'll see that the results, or by default, you'll be searching by carcinogen. If you want to learn more about the industry codes, please refer to this website. This is its Statistics Canada website. Our estimates are organized using the 2012 North American Industry Classification System. And here's an example of what the StatsCan website looks like. I pulled up some industry codes here, and it's pretty useful in describing what the industry includes and also excludes if you're not too familiar with the coding. Using the drop-down menu in eWork, you can either search and scroll for the carcinogen of interest, or you can also just type it in. So I'm going to do diesel engine exhaust here. And by default, results will be presented at the 2-digit industry level. So these are the more high-level industry results. If you want for that specific, if you're interested in the breakdown of a specific industry code, you can click on industry breakdown and we'll pull those estimates up at the 4-digit level. That's here. However, if you wish, you can also just search by 4-digit industry results. And then you can also search by industry. Again, you can use the drop-down, or you can search for the industry of interest. And then you'll have the carcinogens listed here. The occupation tab is very similar to the industry one, except that, of course, the results are by occupation. So here we use the 2016 National Occupational Classification System. And again, we've linked to the Statistics Canada website here. And it's so useful if you're not too familiar with the codes. And also if you're familiar with the codes, I refer to this quite often. But there are descriptions of what the different occupations are, as well as illustrative examples and exclusions and duties. And otherwise, the search features are very similar to the industry tab, except for the fact that we only present data at the most detailed occupation level. So that's at the 4-digit level. And then finally, we have the province tab. Once you click on province, you'll be asked to enter the province of interest. So I'll choose Ontario for you guys. And then the main page shows the carcinogens for the estimates for all the carcinogens for that province. But you also have the option to sort by industry or by occupation, similar to what I had described before. And yeah, I think that's it for the live demo. I'll just X out of that. Yeah, I think it's pretty intuitive to use. We're very excited to have launched this past month. We're very pleased with the feedback that we got from our stakeholders and think that it'll be much more useful to you. But yeah, if you have any questions, please let me know.
Thanks so much, Ella. And I threw in the eWork tool that Ella was demonstrating in the chat. And any questions for Ella? We have a quiet group today for questions.
Hopefully it's just that easy to use. There are no questions.
Well, it's, again, in terms of our prioritization work, and I hope people access it. You can see the pattern that what we've tried to showcase today, just giving you everyone as much knowledge for your joint health and safety committees and your, where you're going to start your risk assessments and how you're going to control your hazards when they come to illness prevention, because oftentimes, people focus on traumatic injury, and we really want to talk about chronic illness and prevention of that, just because latency exists, just to keep as much of that up. So we want to give as many tools as we could today to do that. If there's no other questions, I'll let Kevin share one of our little tools as well that we're releasing in follow-up to his discussion. Thanks, Ella. Thanks so much for coming. In follow-up to the diesel exhaust session we did on November 3rd. Kevin, over to you, Kevin, to showcase this tool that we are going to launch. It wasn't quite ready. He talked about it in his presentation, but we thought we could do a demo in the tools section today. It would fit a lot better. And then I'll include the diesel particulate project window in here as well in the chat. Thanks, Kevin.
Hopefully, thanks, Kimberly. Hopefully everybody can see this on the screen.
Yep, looks good.
It's showing. So really, this has been taken some time to put together. It's actually from a calculator that John Udick originally developed. So it was on an Excel spreadsheet, and he actually did that as a favor for me many years ago as part of a retrospective exposure review, just to figure out whether, you know, the lung cancer for this person working in a garage was related to his diesel exhaust exposure. So we talked about actually making this available as a calculator online. And if you think about, there's a process out of Belgium called the Sobane approach. So by putting these tools in the hands of workers, then the problems can actually be solved at the workplace level. So you kind of like, if you know what the risk is, you're more likely to protect yourself. So, you know, this is kind of it's a powerful calculator. It's like a risk communication tool. It allows workers to assess their own risk of getting lung cancer based on their job, level of exposure to diesel fume, and how long they have been exposed. If the level of risk is clearly communicated, then this should motivate reducing exposures through actions of workers, unions, employers, and the government. It also provides a mechanism through which decision makers can set health-based occupational exposure limits by following the science. So I'll show you what the calculator looks like. So this is a 15-year lag calculator, and there's some background to the calculator there. So basically, it's based on a meta-analysis published by Rolf Vermeulen, where he's combined trucker studies with minor studies to get a big data set. And that's the calculator there. So you can do two things. You can actually, if you know the exposure, so, you know, just hypothetically, I'm going to put in the proposed limit from the ministry, which is 120 micrograms per cubic meter, or 0.12 milligrams per cubic meter. And, you know, for somebody who's been exposed for 20 years, I'll calculate that. And then you can see it gives me a cumulative risk exposure estimate, 15-year lag. And then it gives me a relative risk of around 1.97, so 2. And it also provides confidence intervals around that mean. So, you know, it's kind of almost you're getting twice the level of risk of getting lung cancer at that level compared to somebody who's not exposed to diesel exhaust in mining. It also gives you the option of, for example, if you want to pick, say, a diesel mechanic, for example, then it actually plots in an estimated exposure from the literature into the calculator as well. And then if we calculate that for the mechanic, we end up with a relative risk of 1.26. So on the same portal here, you can see that there's some previous webinars for diesel exhaust and transportation in the community. A lot of the controls are actually, a lot of the practices and the controls are put in the website Prevent Occupational Disease. So this is kind of a living portal. Every time we get new information, we can enter it in there as well. And also, this is just a link to the last webinar that gives you more of the background around the tool. I also want to just make note that there is tools here. I can't seem to find at the moment. There is another way to get through this to this particular tool by looking at the tools portal.
It's right at the top there, Kevin. Apps, tools, and calculators. Just one down from where your mouse is at.
Oh yeah, sorry. Here we go. That's tools and calculators. So we can also get here as well this way, and then you can see all the different. There's the chat tool, the risk tool that Thomas talked about, the ventilation tool, and then the diesel exhaust. So this kind of provides some information there as well, and it's just another way of getting to the tool. But here we've also included more information as well. So that's kind of it. Kimberly. So the idea is just anybody can do the assessment themselves, figure out what the risk of getting lung cancer is in mining and other industries, and hopefully this will influence change in workplaces. Thanks. Back to you.
Excellent, and stay tuned, folks. We have a whole working group working on, this. We create these tools, and we always want the continuous improvement. So we want to provide some additional possible control banding up front in the tool where you don't know the exposures, possible controls out on the other end. So we are looking. We are looking to improve the tools, but we did want to launch it. And I was from the session, you can go back to the November 3rd session on the diesel exhaust that Kevin moderated, and I threw in the chat window a couple things he mentioned: prevent off disease, the crush. They spoke, crush and USW are providing a town hall at the Steelworkers Hall in Sudbury, December 8th from 6 to 8 around the diesel particulate project. For those interested, I did want to make a shout out to that, and there's more information on our website about that as well, and the Crush website.
Sorry, can I also make a shout out to Keith Burney, who's with Workplace Safety North, and Workplace Safety North have been doing a lot of work in this area as well. So you might want to look at their website. Thank you.
Thank you. Yeah, Keith is here, so welcome, Keith, and Workplace Safety North, and OCRC also helping a lot in this area. So lots of info. Hi, Keith. So I wanted to leave the closing. We opened up our sessions, and please do, Jennifer, I don't know if you want to throw up the October sessions. It's been 5 weeks. We put together a really great program. I want to thank all of the speakers from today, but also all the way along the sessions. We hope that please go and revisit. We realize a lot of our viewers, I'll say, aren't able to attend in person because they're working. And we are really trying to archive and allocate, we find that we get a lot of uptake on the video archive of these events. So the Healthy Worker, Healthy Workplace initiatives, the Silica tool, along with Dr. Joel Moody, our Chief Prevention Officer, kicked us off at the first session, and we're going to close out with words from Dr. Moody as well. We've wrapped up after the diesel exhaust exposure, trying to influence change, which Kevin moderated, and we've shown you a tool and just reminding you about that session. So please check that out with all of our speakers around diesel exhaust exposure. And then we talked about occupational exposures and community responses at our November 10th session, and heard, from some great folks and the nail salon workers, and about cytotoxins in the workplace that people may, we tried to catch on some emerging issues, the lens of equity and the vulnerable, really aligned with our illness prevention steering committee work and our work at OHCOW. And the 17th, thank you to OCRC and IARC and Health Canada. We really wanted to talk about, how the worker's voice throughout this whole session, that's why we called it Worker Focused Science and Prevention, throughout the webinar series. The collaborations and learnings, both locally with our cluster projects or our clinic work, and are important, bringing to the surface, some trends that we find in this work, to the research organizations, and our piece of the surveillance in the community, and then collaborating provincially, nationally, and internationally with some of our example clusters, and then the firefighters. And then today, hopefully making it all easier and pointing to some of the tools we're developing to do something about this. So with that, I do want to hand over closing comments to our Chief Prevention Officer, Dr. Joel Moody. Joel, I didn't get ready your bio. It was silly. I'm tired, I think, after 5 weeks.
It's quite okay, Kim. It's not necessary. I'm just happy to be with you all again today. Thank you so much. From the standpoint of what I see from our colleagues at OHCOW, the great opportunities that we have. And it's very fitting, Kim, that you talk about, the October series, worker-focused science and prevention. And I think that is really the part of the puzzle that we have to always remember, because at the heart of all of the work we do is the individual. It's the worker, and how and what they do, how and what exposures happen. End of the day, we want people, and especially for me, prevention of occupational illness, injury, disease. Full stop. That's what our job is, and that's what we're trying to do. And so hearing some of the speakers, I was able to tap in a little bit today to hear about, the final session about knowledge mobilization and the tools. Very fitting, because, we talk about how do we move that available knowledge into active use. And from, the side of the ministry, very interested in how we can continue to make positive change. Through legislative aspects and even non-legislative aspects. So it's very important that we keep mind of both. For me, it takes me back to some work that I did when I was much younger, less gray. But I did a project working on hazards with wastewater treatment plant workers. And so it was just around the biological, chemical, physical hazards that one would encounter through their day-to-day operations. And so being able to help articulate, how the science was evolving, being able to articulate what were some of the preventative strategies that existed, not only from, a PPE perspective, because we know in the hierarchy that's at the very bottom, but even what are some of the ways in which the chemicals could be potentially, repurposed and things of that nature. So very important to help people understand such that informed decisions can happen. And that's what you're doing with the Silica Control Tool, the one that's here in Ontario. And thank you so much for being able to take knowledge, existing science, mold it, for the Ontario population. And, that's one of the things where we are demonstrating active work of putting things into action. And that's consistent with the Ontario Works, the prevention strategy that we have, that prevention works. So super, super excited about that. Don't want to repeat myself, but this event is something that we need to continue to have each year, because it continues to build awareness of the importance of occupational disease and illness, because we know that the knowledge base is constantly improving and changing. You talk about work that's done at IARC. I was just actually 2 days ago at the Section 21 committee with our firefighters. And so being able to understand, what has come, from a PFAS, all of those different aspects that we're now trying to understand better with the goal of prevention. Because we do know that on average, occupational illness and disease has, effects sometimes larger than the physical traumas that exist and the physical hazards. So we want to remain focused about prevention. We want to remain focused about a preventative, proactive approach around occupational illness and disease, because that's at the forefront of what we are all trying to do. As an epidemiologist, as a clinician, with my colleagues as well, with our hygienists, with those that do therapy, we all know and we all recognize prevention is truly the key. Being able to deal with an unfortunate incident later has greater complications, and sometimes those complications relate to a much decreased quality of life, and then sometimes even around the ultimate, which is the fatality. So we always want to be mindful. Let's move our ideas upstream, prevention, and that's the main focus. And that's why it is a focus of mine, and that's why it's a focus of the minister, and that's why it is a focus of the system as we move forward. So once again, thank you so much for allowing me to come and bookend our sessions today. So and OHCOW, I want to say thank you for being a very integral and necessary part of our system and making this event possible. All the best.
Thank you, Joel. It's really great to have you give our closing words and our kickoff welcome. It just really solidifies the commitment and to that the prevention office has to this good work, and hopefully inspires more people out there preventing occupational illness and joining us in our work. So with that, we will bid you all adieu. Look for some COVID conversations in the works coming up. We have some podcasts being released. I just got notice about today. So keep returning, revisit some of the archived sessions. And I thank you, Dr. Moody. Thank you to all of our speakers today and over the last 5 weeks. And please hope that we have motivated folks to help us in our journey to prevent people from getting sick and sharing all this knowledge and these tools. So share. So appreciate it. Thanks, everyone. Have a great afternoon.